Now
that will make the things simpler.
Yes, now it's a lot
Yes.
simpler. Thank you, my dear friend. Professor Datta?
Yes, sir. Yes, sir.
Well, now I'm typing. I'm sorry about a
Yeah.
small mistake as usual.
Okay. No. Yeah.
Well, let me laugh.
Yeah.
Well, I'm going to say that again. I'm very happy to introduce you to Professor Debabrata Datta. He's a very well-known Indian scientist. And I said that when I read his CV, I was very impressed. And of course, I'm very grateful to him. He's a member of the organizing committee of this international web seminar, as well as Professor Rashmi, Brapach, and any problem with the communication?
No.
Yeah, and also to Professor Johan Roll from the USA. So in this opportunity, Professor Debabrata Datta is going to give a talk on an arrow of time in research and education. Professor, you are more than welcome. Please, I wish you the best of luck. And I'm going to be really looking at the screen, okay? Please, you can start.
Okay. Yeah, okay. First of all, thank you one and all to give me this opportunity for sharing some of my thoughts, this philosophical talk. It may not be that mathematical, but conceptually it is very deep understanding, as the many great scientists have also given a thought this particular topic, an arrow of time in research and education. So I have tried to do something to that, to map with the recent COVID-19 pandemic, how this arrow of time is taking us towards the future perspectives in the different lines, especially towards the research and education. So let me start with this, my slide. I think that the slides are visible.
Yes.
Yeah. So, yeah. So this is the topic I have made that. I will be describing about the concept of time arrow, which is really a philosophical rather. Some scientific thoughts are always there. Perspectives of time arrow by various scientists, and 7 arrows of time we are having so far today. Entropy and its various forms will be the representation form of the expressing the arrows of time. Then we will learn with the time arrow what we have learned and what we are going to learn. So this time arrow finally will map to the COVID-19, which will direct us towards the research and education change over. And then what will happen in education in 2030? Today is 2020, so after 10 years, what will be the impact of this particular COVID-19 pandemic after 10 years? So I'm just touching upon the education, because education may be a very big, may not be able to explain properly, but definitely we will highlight some of this thing, and with that we will conclude that. So let us see that how best we can do. The first slide, it will give you that is some kind of discover. It is one way. If you read that, in the universe of both Newton and Einstein, time flows backward into the past, because as it is does forward into the future, and which means that we should all have memories of the future. So that means that we would like to have our memories for the future. So how this memory will grow, the talk will highlight many of the things. So therefore we can say that that physicists cannot find a single arrow of time that points in any direction but ahead, is one of the most profound and vexing, mysterious in nature. So this was discovered long back by both the scientists Newton and Einstein, because Newton has started the physics. After some time, Einstein modified by putting the relativity theory concept. So therefore, we would like to know that arrow of time. What is that arrow of time basically? This is a question many people have now also. So the arrow of time, whatever I could survey the literature, and I found it out with my perspection that the arrow of time, also called the time's arrow, is the concept of posting positing the one-way direction or asymmetry. So time, if it moves in one direction, we call it is an asymmetry. So we call that the arrow of time is basically an asymmetry of time. You see that it was developed in 1927, long back, by the British astrophysicist Arthur Eddington, and is an unsolved general physics question till date. So understanding the time is very difficult, but everybody has tried on their perception. So today with this webinar, I am also trying to just give the thought, what is the time arrow and where we have reached so far. If you look at the Arthur Eddington in 1931 has given this concept that he has taken the second law of thermodynamics in another view and has said that a universe containing mathematical physicists will at any assigned date be in the state of maximum disorganization, which is not inconsistent with the existence of such creations. And then finally, with that perspective, he has coined that the entropy is basically the times arrow. So according to Arthur Eddington, we have so far knowledge about that the entropy is the physical parameter which is mentioning that the times arrow. Fine. So we can also see that while time is an extremely intuitive notion to we humans, we have a hard to explain what exactly it is. We may have the doubt and certainty. We always have uncertainty, but that uncertainty, to mitigate that uncertainty, we also have to bring that what is doubt and what is certainty. If you look at that, this particular concept has been thought by Stephen Hawking, and he has given a perception about the arrow of time in the three modes. One is psychological time, one is entropic time, and third one is cosmological time. So according to Stephen Hawking, the times arrow or arrow of time can be looked at in a different angle, especially in the three modes: psychological, entropic, and cosmological. So we can explain a little bit inside of the psychological time, and this corresponds to the human perception of the time. Things we remember are in the past, basically. Whatever past has happened, sometimes we remember. We know we have moved forward in time if we can remember more things now than we did it in a previous moment. So many people just jacked over the past. So definitely the present things they almost do not care. So they always try to remember the past. So ultimately that psychology is a matter where we have to step in. Similarly, entropic time, if you see, this notion of time corresponds to the perceived law of nature, that the universe seems to be preferred moving from a state of order toward a state of disorder. So we are all having a civilized society, order, all on a sudden this pandemic situation came. So every country, everywhere that we made a disorderness. Okay, so we have moved from order to disorder. So this must be the entropic time, because entropy always express about the order to disorder. Then cosmological time. We won't discuss the framework time very much, but this arrow moves forward when the universe is an inflationary state. This is a very important topic, that is the inflationary state, and backward when the universe is in a differential state. So you can think of the university that the two state, one from the inflationary to deflationary. So whenever this transition of the state takes place, we can say that we have a cosmological time. So fine. So time shadow, if you look at right from the very beginning of this thermodynamics, Clausius' famous statement was that he has coined the second law, that entropy of the universe always increases. It starts from the Clausius and he has given this topic. Then this statement, the entropy always increases. Why always? What is the meaning of the always? Always means that entropy always increases with time. Okay, as the time moves, entropy also moves and moves towards the positive direction. So entropy increases. However, strictly speaking, statements like entropy always increases it must be a meaningless. Okay, there are many scientists who has debatable issues regarding this thought, and then we also say that the entropy changes are meaningful only for well-defined thermodynamic system. So if you really describe the pure thermodynamic system for which the entropy is defined, well, okay, we can understand that the entropy changes takes place. But in a social life, if we talk about the entropy change, that sometimes it is having some meaningless. So therefore, that's why I feel that the entropy always increases. These are meaningless with respect to the social behavior. Once you specify the system, then its entropy is determined. So therefore, before defining the entropy, we have to understand ourselves that what is the circumstances where we are going to define this entropy. And here we also know that at this juncture that entropy does not change with time. So one way it is the time, another way it is entropy. So these two things we are going to discuss. Now if you look at this example, that one of the single most surprising things about the universe is that things always change. So Earth is rotating, universe is changing, so everything is changing. So in that only forward direction, if you look at this example, eggs break, but ice cubes melt, stars emit radiation. So we record memories of the past, and it all happens in a consistent direction from the past to the future throughout the universe. So this concept, when it is happening, we call that the arrow of time. That means we are pointing a fact towards with the help of the arrow in the right direction. If you look at here, Professor Joel Lebowitz, the Department of Mathematics and Physics in the Rutgers University, he has expressed his thought that the arrow of time expresses the fact that in the world about us, the past is distinctly different from the future. That means he has also called that the milk spills but doesn't unspill. Eggs splatter but do not unsplatter. Waves break but do not unbreak. We always grow older, never younger. So that means we are always going towards the right direction. And these processes, that is why all move in one direction in time. They are called time irreversible. And that defines the arrow of time. So we can think of the arrow of time is describing the time irreversibility. So therefore, it is therefore very surprising that the relevant fundamental laws of nature make no such distinction between the past and the future. If we think about the time irreversibility, then many of the time philosophically we will see that what is past, what is future, we may not be having any capability to distinguish them. Anyway, if you look at the more and more debatable and the philosophical concept, we can really crunch our concept towards what is exactly the time arrow. One of the deepest paradoxes of modern physics is that microscopic physics is time reversal symmetric. So what I thought about if we look at the physics, we can again break the physics in the two modes. Like our universe, we have given that the inflated or disinflated. Here also that the complete physics we can break into two modes. One is microscopic, another is macroscopic. So microscopic physics is time reversal symmetric. But if you look at the nature, but nature is not. So microscopic theories of physics do not care which way that the time goes. So for example, the Newtonian mechanics, where we never discuss about the direction of the time. Electromagnetism, we never discuss about the direction of time. Relativity theory, time imparts, but we never discuss exactly the direction of time, even in the quantum mechanics. So these microscopic theories never care which way time goes. They always stand on their own laws. So if you see that nevertheless the nature cares, so that's the thing already microscopic theory does not define. It is a time reversal symmetric. So with respect to all these processes, with respect to all these concepts, Eddington's again coined that a special view on the time shadow, and he said that the law that entropy always increases holds, I think, the supreme position among the laws of nature. Let us draw an arrow arbitrarily. That is his perspective, that if as we follow the arrow, we find more and more of the random element in the state of the world, then the arrow is pointing towards the future. If the random element decreases, the arrow points towards the past. So he has thought about from a random element. Okay, so if I repeat that, if the random element decreases, the arrow points towards the past. If it is increasing, then arrow is pointing towards your future. So this follows at once if our fundamental contention is admitted that the introduction of randomness is the main thing, only thing which cannot be undone. So we are focusing towards the introduction of randomness. So there is a debatable issue with this Eddington's perspective of the time arrow. Eddington is credited for the explicit association of the law that entropy always increases with time arrow, which expresses the one-way property of time. Two relevant quotations from Eddington's in 1928 popular book, There's the Nature of the Physical World. One is that the first concerns the role of entropy, and the second was that it introduces the idea of time arrow. So these are the two important concepts has been explored in this book. So now if you see that the statistical time concept, so as I mentioned that we are trying to map the order disorder, so we have to bring the statistical mechanics. So statistical time concept that entropy is equal to time's arrow has the deep and fascinating implications. So it therefore behaves us to try to understand entropy even more deeply. So we have to understand what is entropy. Entropy not only explains the arrow of time, it also explains its existence. It is time. So that means time is there only because of the entropy exists. So therefore, what is our conclusion so far with all these debatable issues and all these things? We can say that it is clear that an arrow of time exists. Here is another typical quotation from Rifkin's book associating the entropy with the arrow of time. The quotation is here. The second law, it is the irreversible process of dissipation of energy in the world. What does it mean to say? The world is running out of time. Simply, we experience the passage of time by the succession of one event after another. And every time an event occurs anywhere in this world, energy is expended and the overall entropy is increased. And this is a fact many other times we have seen. To say that the world is running out of time, then to say the world is running out of usable energy. So if energy finishes, then what will happen? So then question comes here, why does time have a direction? If you look at this particular equation, that is very simple, rate of change of momentum but be mapped with the gravitational law by Newton. And if we change the time to negative time, momentum to the negative momentum, whether this remains same. So that means it is understood that whether any kind of physical laws are invariant under time reversal. Okay, so this is a point that need to be mentioned, that whether our system is invariant under time reversal. First one, we have seen that the time process is an irreversible process, because when eggs splits, it never unsplit. If milk boils, it never unboils. So like that kind of thing is a asymmetric part. So here again a common answer to why there is an arrow of time is with the framework of the entropy and the second law of thermodynamics. The second law is not invariant under time reversal. As we mentioned that a system has to be invariant, time invariant, and if it is time invariant, then only we can think of the conservation of energy, or conservation laws basically mapped with respect to the time reversible process. But here you see that the second law is never invariant, not invariant under the time reversal, because we always see from the second law of thermodynamics, the rate of change of entropy ds by dt is always greater than or equal to 0. So that's why second law of thermodynamics mentioned that entropy always increases towards the time. So with respect to that, Roger Penrose came, who is a cosmologist, very famous cosmologist. He has said that it's not quite that simple. So he lists 7 ways in which the nature distinguishes the past from the future. Our only thing is to always understand that what is past and what is future. So Roger Penrose, as a cosmologist, he mentioned that 7 ways that the arrow of time can be represented. What are the 7 arrows of time? It is very interesting to know that according to Penrose, 7 arrows of time is the memory arrow, electromagnetic arrow, quantum arrow, black hole arrow, cosmological arrow, Count arrow, and entropy arrow. Every arrow has got its own base. But we are not going to discuss all these arrows. But since the topic is that the arrows of time and entropy is one of the important parameters, so we are discussing only the entropy arrow. So therefore we mentioned that we are interested mainly in the 7th arrow. Okay. Anyway, just to have a pass through that, we can understand that what is memory arrow. Memory only works in the backwards, because we always remember the past. So that means it is a backward. We never remember the future, because future we do not know. So how do I remember? So therefore, we say that the memory only works backwards. So if you look at the memory arrow, time is the backward direction. If you look at the electromagnetic arrow, electromagnetic causes always precede effect. So that the principle of causality, which has been explained by the electromagnetic. So here it is only some kind of rotational translation, and with respect to certain type of the electric field and magnetic field, like Poynting vector, if you look at, it is nothing but the electromagnetic arrow. So then we have the quantum arrow, where it is very important to understand that the wave functions collapse, but they don't uncollapse. I have shown here the picture, which is nothing but the Schrodinger cat. If you look at the wave function collapse, but they do not uncollapse. So because of the quantum arrow, thought by Richard Feynman long back, that there is a possibility of quantum computations. And we have seen that the quantum computing is coming. It has come to some extent in some part of the world, but not everywhere, and not getting popularized so far because of the hardware limitations. But some point of the time it will come. So time has moved towards that direction, where quantum computing will be the one of the challenging computation. Then black hole arrow, and many of the people, you may be knowing that the black holes exist, but white holes does not. Because if you look at the hole and electron, in absence of electron, only we think about the hole. So here also same thing. In absence of black hole, we can think about the white hole. But white hole we never discussed. We always discuss of the black hole. So it gives the black hole arrow whether black hole exists or not. So apparently it can mention like that. Then we have the cosmological arrow. We live in an expanding universe, not a contracting one. Would time change direction if the universe started contracting? Then we have a Count arrow. Here it is very simple that Count decay. Count is a particle, strange particle, and it has got some strange number. In the realm of the particle theory, we know that the Count is a group of 4 mesons, that is pi meson and mu meson, pi plus minus, mu plus minus, and they are distinguished by their strangeness quantum number, and they can be mapped by use of the up quark and down quark. And therefore, Count decay is not the time reversal symmetric, as I mentioned here. So theoretically, we can say in a time reversed world, this particle would decay at a different rate than in our world. Okay, so if we have a time reversal world, this reaction will be totally different. Then finally, from this we came to know that there is a very famous theorem, charge conjugation, parity, and time reversal, CPT theorem. And based on this theorem, that the complete particle physics stands, and Gell-Mann-Mass-Okubo formula will be based on that. So CPT is basically charge, parity, and time. Here we wanted to say that everything that a charge conjugation, then parity, and time reversal. If this is there, so this new world would be indistinguishable from the old world. So what is old and what is new? If you go back to the 1920, and if you go back to the before that, when the human just developed from the monkeys, so you will see that that world and today's world are the same. Then whatever that they were past, same thing in the future. So world does not move, but it never happens. World has moved, and so many things have come in the many directions. So therefore, there must be some direction of time. So this is the meaning of the CPT theorem. So there is an experiment in Princeton that is called the Princeton experiment in 1964 found that kaon decay is not invariant under CP reversal, and kaon decay must also change under the time reversal. So these are the experimental conclusions from that experiment. The seventh one, which you are going to focus on that, which is the entropy arrow, arrow of time, that is the most relevant to this course. Therefore, we can say that the total entropy always increases. That's something everybody we know because of the second law of thermodynamics. It directs about the entropy. Okay. Then if you look at that, this law, second law of thermodynamics, in any process, the entropy of a system always increases under realistic condition. What is the realistic? It is irreversible. So the time phenomena is irreversible. It never goes towards the backward. This is the only law of nature which exhibits a direction of time. So direction of time, if we wanted to understand, we have to understand the second law of thermodynamics, which is described by some Clausius and many other scientists that this already mentioned. But main point is that the realistic picture is that the irreversible condition. So thermodynamically, arrow of time can be viewed as, in an isolated system, entropy tends to increase with the time. In an open system, entropy can decrease with time. So therefore, arrow of time is based on second law of thermodynamics. So now, what is entropy? As I mentioned that, we can think of the entropy as the different perspectives. Entropy is a corollary of energy conservation, which is giving a first law of thermodynamics. Energy conservation we obtain from first law of thermodynamics, and entropy concept we obtain from the second law of thermodynamics. So entropy is a corollary of energy conservation, and because of entropy, we are allowed to use and transform energy. Function of entropy is so fundamental to energy conservation that it is built into the basic structure of energy itself. So entropy is not the optional. In free electromagnetic energy, this embedded that primordial entropy drive that is expressed as the intrinsic motion of light. Because if you look at the light wave is a mixture of the electric field and magnetic field. So intrinsic motion of light, we never discuss about the time there. So intrinsic motion of light, creating, expanding and cooling space, the conservation domain of the light remains the same. Again, in the bound electromagnetic energy, which is an atomic matter, the embedded entropy drive is the intrinsic motion of matter. There is a time dimension causing the decay of matter, like a radioactive half-life, the expansion, dilution, and aging of history. So aging of history is very important. So we can say that we have a time machine. Historic space-time is the conservation domain of matter's causal information matrix. So therefore, there are various forms of entropy. We know what is entropy, how it is mapping with the time. So still there are various forms of entropy. This part is very important that we never thought of the different forms of the entropy. Here, if you look at we have an entropy called special entropy or primary entropy. This particular aspect is discussed about the cooling space or expanding space. Secondary or historical entropy, it discusses the entropy of bound electromagnetic energy, mass or matter. Third part is the gravitational entropy, which is a negative drive of special entropy. And then we have a gravitation and entropy. They are always entangled with each other. And if you see that the time is basically the product of the gravitational field of either mass or matter, and gravity annihilates the space, revealing an explicit temporary residue that formerly had served as the implicit drive. So light's intrinsic motion, main point is that it is nothing but the light's intrinsic motion. So time is the product of the gravitational field. Now gravity is the conservation force, as we know. So therefore it always converts the special entropy drive of free electromagnetic energy into a intrinsic motion of the electromagnetic energy. So therefore we have the space-time concept in the entropy. Earlier we have the only time concept, but no, we may have the space-time concept. So we have a spatio-temporal entropy. So it is a tertiary form of combined entropy. If you know that the entropy, that the familiar relation is ds is equal to dq by t, and then from that the Boltzmann explained in terms of the probability theory as a S is equal to K log W, where W is my mathematical probability. So for any disordered system, I can find it out that the log of the probability, then by multiplying the Boltzmann constants, entropy can be defined. Then we have an information entropy, where Shannon has coined as a negative sum of the expectation value of the, you can say that the expectation value of the logarithm of the probability, because when any quantity multiplied by the probability and take the summation, assuming that the probability is normalized, it is nothing but the expectation. So Shannon entropy is the negative expectation of the logarithm of the probability. And this also describes about the chaos theory. So again, in the spatiotemporal entropy, you can think of the biological domain. Biological domain has its own source of genetic positivity in the form of the mutation and sex, and likewise its own form the negative entropy in the form of Darwin's theory, that is natural selection. So acting together, this biological entropy drives create the conservation. So the domain of molecular information contained in DNA. So if you look at the genetic disorder, so definitely entropy also can be defined there. And genetic disorder means as we move from one generation to another generation, the time has a direction. So summary, so far we understand that the entropy can be thought of as a quantity proportional to the waste heat generated in any realistic process. Entropy can also be thought of as a measure of the disorder in a system. Essentially, the entropy relates to chaos theory, giving an idea that the system leans towards the disorder. That is something that is unpredictable. Disorder means is unpredictable because a lot of probability concept is there. So this implies that universe is a chaotic system. So far we learned now universe is a chaotic system. So therefore what you have to do, we have to remember this following fact sheet. Information is one way. So that is asymmetric due to the causality as well as due to the absence of antimatter. Because we know that every matter has got the antimatter. This is a particle wave nature duality. Every particle, because of the existence, it has got the wave proved by the de Broglie's hypothesis. So therefore, here also we can say that every matter has got the antimatter. And if you see that the proton has got the antiproton, neutron has got the antineutron. So electron has got the anti-electron, which is a positron. So therefore, information is one way asymmetric. Gravity is the one way and asymmetric. Time is one way and asymmetric. Entropy is one way and asymmetric. So therefore, these are the fact sheet. Information is asymmetric. Gravity is asymmetric. Whatever the information you have gained, you cannot just go back. Gain means already gone. Then you have to proceed further. So the matter is asymmetric due to its time dimension. That means time is moving only in the positive direction. It never moves in the backward direction. So always everything is asymmetric. It is a one way. So therefore, there is a philosophical questions. Again, debate among a lot of cosmologists. Hawking mentioned that the memory and entropy arrows are linked together. Rothman to Penrose is given the thought that one arrow is arbitrary, so there are only 6 independent ones. Sudarshan and Rothman, they coined that all particle decay is CPT invariant, but such decays are irreversible, so particle decay arrow. So they mentioned that the particle decay arrow. Rothman to Sudarshan then again question that is there a temperature dependence to these decays? So that means they are trying to bring some another concept that the way that the temperature can be invariant or not. That may be the fact that initially that many of the people have thought that the COVID virus may be that the temperature dependent, but it is not. Initially people have thought it is not. So therefore we have to really think about that, where we are going. So here if you look at entropy measures the volumes in phase space. What is phase space? It sets of macroscopically indistinguishable microstates. So this is a very important statement that phase space is basically sets of macroscopic indistinguishable item in the microstate. So if you look at now Boltzmann, he has given that the total entropy increases because there are more high entropy than low entropy microstates. Every scientist has got his different own thoughts. So starting in a low entropy state evolving to a higher entropy state. That is only natural. He has described that. And that is why he has given that the Boltzmann entropy. Penrose, he has mentioned that the lower entropy near the Big Bang is responsible for everything about the seventh arrow of time. Life and death, biological evolution, memory, the flow of time. And questions are that, why are not we in thermal equilibrium? Answers are controversial issues in cosmology, because we cannot think of that cosmological viewpoint, that the cosmological entropy, that we may not be in thermal equilibrium. So a great puzzle in turn appeared in many literatures. You can find it out that one of the things I wanted to mention that if you look at that, how can time reversible motions of atoms and molecules, the microscopic components of material systems, give rise to the observed time irreversible behavior of our everyday world. So in our world, time irreversible behavior is taking place. So the question is that how we can frame this. Resolution of this apparent paradox is due to Maxwell. We have the Maxwell corkscrew rule, left-hand rule, but we never have Maxwell's right-hand rule. But if you look at that the Fokker-Planck equation and coined it by fractional calculus, you can find it out Maxwell's right-hand rule also. Like Faraday's Fleming's left-hand rule, Fleming's right-hand rule. In case of that, Maxwell's right-hand rule also is available, but with the help of the fractional calculus, not by. But why such kind of another physics to be brought into picture? So that means that we have to move towards the right direction of time. So back to entropy and the arrow of time, we would like to consider a thermodynamic system, a many particle system, perhaps a gas, which obeys the second law of thermodynamics. However, the individual particles in the system obey either Newton's laws or some quantum mechanical laws. So the question comes again, can entropy decrease over time? To answer that, we see that the entropy decreases in a working refrigerator. This is true fact. If we apply the Joule-Thomson effect, which is an isoenthalpy process, we can always prove that entropy decreases in a working refrigerator. So entropy decreases during the growth of a crystal. This is a fact. So when entropy decreases with respect to the time, because growth of a crystal is time moving. So is that idea that entropy also decreases over the time? So therefore we see that we know in living systems, local entropy is reduced at the expense of an environmental increase. So here we are basically thinking about the relative concept. So because of the second law of thermodynamics, entropy prevents macroscopic processes showing that the time symmetry. T symmetry is nothing but the time symmetry. So if you see that the microscopic, the reversible, macroscopic, irreversible. So the raindrop splash and displacement of soil particles, but we can never get from that what is the raindrop. Is not possible. So the observations at microscopic and macroscopic scale is that when you study at a microscopic scale, the judgments of preventing that the macroscopic processes showing that the time symmetry that cannot be made. But what is time symmetry? It is basically symmetry in nature. So therefore, how does entropy relate to the time? Well, first one needs to relate entropy to physics. That is a typical example in a thermodynamics, is a very standard example, a box of gas. Hawking argued that the first two notions of the time are the same. One is our brains are made up of pairs of neurons. Okay, because Stephen Hawking has got the motor neuron disease, which has got certain special phenomena. So memories are formed by these pairs of neurons orienting themselves in a particular way, and thus our memory, we can say that it increases when entropy increases. So he's pointed out that our memory increases when entropy increases. So therefore, the two arrows must point in the same direction. One is memory arrow, one is entropy arrow. So if entropy increases, then only memory increases. Entropy increases with respect to time. So when time increases, memory increases. And when you increase the memory, our learning capability increases. So therefore, the complete artificial intelligence we can thought about why that it came today. Why not it appeared that when Einstein discovered the relativity theory. So therefore, it has got some direction of the time. That is the arrow of time I wanted to mention. If you mention that, how is the irreversibility distributed described quantitatively is a mixing of alcohol with water. Is a very simple. We have the initial state which is high entropy, then we come back to the water layer added is a low entropy, and then when the mixture took place, we have the final state which is a high entropy. So entropy is moving towards direction that is maximizes the number of ways to arrange the molecules. That is nothing but the maximizing the entropy. So arrow of time, if you look at, which is a backward direction, unbelievable, but yes, forward direction, it is believable. Again, arrow of time and the free expansion of the gas. If you look at this figure is giving you that entropy from initial state, which is a high, from the final state, again, it will be high. So higher state to low and then again final. Okay. So there is a major paradox here. A many particle system is a thermodynamic system which obeys the second law of thermodynamics. But if the particles individually obey time reversible Newtonian physics, how can arrow of time even arise? It is a time reversible Newtonian physics if it is available. Boltzmann mentioned that he attempted to derive an increase in entropy from Newton's laws of motion, which is nothing but the Boltzmann-H theorem. So basic idea of the Boltzmann-H theorem is nothing but increase in entropy from the Newton's laws of motion. Boltzmann uses the probability theory. We all know that he has described the probability theory. Lost Schmidt strikes back. Then in the discussion, Lost Schmidt came and then he strikes back. He told no, it may not be. And then Gibbs again also strikes back. We know that the Gibbs sampling, if you try to do that the Gibbs sampling, then we can prove that from the Newton laws is not possible to derive the Boltzmann-H theorem. Then Prigogine came, and I heard this lecture when I was an MPhil student at the Shah Institute of Nuclear Physics in the year of 1984. That time really I was not understanding what is time arrow, but today I could realize that. That means my memory also has increased towards the entropy increases or towards the time passage. So the Prigogine solution to this paradox is that second law of thermodynamics is a fundamental laws governing the universe. It cannot be derived from other laws like Newton's laws. Chaotic system intrinsically manifest irreversible behavior. So the second law states that entropy increases due to chaos only. So that is the Prigogine solution. So entropy is mapped to the chaos now, and chaos is basically a disordered theory, equilibrium, non-equilibrium theory. So entropy S is a basically Lyapunov function for the isolated system, and it has been shown in many textbooks that thermodynamic potentials such as the Helmholtz or Gibbs free energy are also a Lyapunov functions for other boundary conditions. Maybe that the imposed values of temperature and volume. So entropy is basically Lyapunov function. So it describes the chaos, because by the use of the Lyapunov function, we can describe the chaotic situation. So equations governing motion in chaos systems are time symmetric. That is the objections, whatever the Prigogine solutions are given. If a system is chaotic in the future, it was also chaotic in the past, because a chaos system in the past cannot be brought back into the non-chaos system or the not chaos in the future. So therefore, we have moved in the forward direction as time arrowed in the similar direction. We are now in 2020. Research on various topics has drastically changed along with the time. Education also has changed accordingly. So therefore, research changes education and education further changes the research. It is similarly like C language programming. When it came, it developed, and by the use of C language, we developed the Unix operating system. When Unix developed, by the help of the Unix operating system, we further developed C language. So Unix development and the C language development, they are entangled with each other. So therefore, research and education also can behave the same way. They cannot be mutually exclusive. That means they are not independent. They are always attached to that. If you increase the education, if you increase the research, automatically it will imperatively improve the education. So the arrow of time and quantum mechanics, if you see, the time has an arrow. We understood so far. The contrast that the time reversibility or even the possibility to run the equations of motion backwards in time is not at all primary requirement. Time is the order in which our models for nature predict prescribe or explain events. According to Shannon, the main result of the definition of entropy is that the entropy is proportional to the maximum of the Shannon measurement of information. We call it short as the SMI, maximum over all the probability distributions of locations and moments of the particles. So therefore, we wanted to learn that how the arrow of time, it is asymmetric progression of time, has a profound effect on how we are doing basically. So therefore, we are trying to draw the inspiration from that. We can address the problem of learning an arrow of time in a Markovian process. Why Markovian? Because Markov process gives the when you forget about your past at the present, then only the process is called as a Markov process. So you are taking a decision in the time frame. We are trying to the risk, making a decision with the help of the risk. So that means uncertainty framework we are trying, and uncertainty is again capped with the disorder order theory. So therefore we can say that we illustrate how a learned arrow of time can capture the meaningful information about the environment. We can think about where we are reachable and whether it is a reward signal or not. So Shannon entropy, everybody knows that it is mathematically coined by h is equal to minus k summation of pi into log pi. But in the integral mode, it is mentioned as the location and velocity. So Shannon entropy also can frame your position and the velocity. So therefore, maximum entropy can be mapped with this. And you know that the maximum entropy, once you coin that, it has given a various applications. Because you know that there is unfolding of neutron spectra is required. Because if you take a neutron spectrum, it has got plenty of energy. We do not know which energy of the neutron is affecting the system. So therefore, we require to unfold it. There are many methods for unfolding, but maximum entropy information, if we apply, this is the best unfolding technique. So in a nuclear reactor, we apply this unfolding technique, and unfolding technique is so important so that every energy you can easily unfold it. And there is a Maxet code developed by Regineto from the Italy, and he has shown that the maximum entropy can be applied to develop this code. And with the help of this code, many of the reactor systems in the global world, they operate. And this is the neutron spectrum of the americium beryllium source. We have to unfold. This unfolding is done by the unfolding, nothing but the deconvolution. So we do by Maxet code. And this is a high flux isotope reactor. Here also they apply the unfolding code by maximum entropy Maxet method. These are neutron source we require. And when you try to do the neutron radiography, you have to really pinpoint which energy you are putting in the beam. So therefore, unfolding is very essential. And we have a pulse spallation source and many of the things. It is just pictorial representation. You see that a lot of energy can be done. And so their system can be there. So this is the neutron spallation reaction. I do not want to describe here because people are knowing. So therefore, new learning is that time arrow point towards the increase of entropy. Memory increases with entropy increase. Learning needs an enhanced memory, and hence arrow of time improved our learning. That is the machine learning we can call. So we have to have a resilient actions. Decision-making process improved by improved learning, which is a machine learning. People became more and more intelligent as time arrowed towards increase in entropy. Well, succeeded decisions adopted to guarantee a system's dynamic equilibrium. Learning helped us to identify the resilient action in decision-making during the emergencies like COVID-19 pandemic. And these are you can see that with the help of that long back, this kind of decision took place. Like, can we learn how counties vote? It is a decision making between Obama and Clinton. So this is a decision tree we developed so that now also we can, current elections, future election is coming in the US, we can think of Trump and Joe Biden so that we can develop the decision tree, and based on that, we can easily see that who is going to win. So arrow of time and quantum computer is one of the important aspects. Researchers prove that arrow of time is irrelevant to quantum computers. Researchers set out to determine if quantum computers could be used to overcome one of the classical computing's biggest problem, that is causal asymmetry. So basically, with the help of the quantum computation, we are trying to remove this causal asymmetry. So therefore, we have shifted priorities in the time of COVID-19. If you look at one or two bullets here, the lockdown further impedes humanitarian aid and daily supplies that this population is dependent on. The tragedy is the wreckage of a train that has been carrying down the track for years, coined by Arundhati Roy. This is available in various news channels, in the newspaper, on the worldwide. Mounting data suggests that domestic abuse is acting like an opportunistic infection, flourishing in the conditions created by the pandemic. So therefore, time arrow of COVID-19 could always change the world forever by 6 ways. What are those ways? If you see that if this is not, then coronavirus pandemic has already transformed our world. So we must reshape our investment strategies accordingly, says David Prosser from Interactive Investor in the May 2020. Lenin could have been describing the COVID pandemic, but he has not. So that means the time has not grown. So what are those 6 ways? As I mentioned that the COVID-19 can change forever world by 6 ways. What are those 6 ways? The 6 ways are the globalization comes to a halt, healthcare goes digital at last, e-commerce and home working come of age, restart for travel, tourism and leisure, real estate faces existential question, climate change efforts in the balance. These are the 6 ways by the way that the COVID-19 can change. So therefore, Arrow of Time has played a substantial role in research and also in education. On the basis of causality principle, an Arrow of Time will dictate the future education and skills 2030. Let us see a glance that what is the 2030 education it looks like. This is the situation will look like. You see that the children entering school in 2018 will need to abandon the notion that resources are limitless and are therefore to be exploited. They will need to value common prosperity, sustainability, and well-being. In the face of an increasingly volatile, uncertain, complex and ambiguous world, education can make the difference as to whether people embrace the challenge they are confronted with or whether they are defeated by them. So therefore, some kind of system should be changed. From that, we are already changed. We were never used the online platform. So we are using the online platform. This is itself is a change of the education. So need for new solutions in a rapidly changing world, that is societies are changing rapidly and profoundly. A first challenge is environmental, climate change and the depletion of natural resources. Second challenge is economic. We know that the many kind of things, and so therefore unprecedented innovation in science and technology, especially in biotechnology and artificial intelligence, will play a havoc role. And biotechnology, as you know, that this is the basic forum for the vaccine research. So a third challenge is the social. As the global population continues to grow, mitigator, migrator, urbanization, increasing social and cultural diversity, they are reshaping countries and communities. And in a larger part of the world, the inequalities in living standards and life changes are widening. At the same time, the threats of war and terrorism are also escalating, which we are seeing that the China-India clashing are going on. Though it is cool. So Arrow of Time will dictate that the following to shape future education: need for a broad set of knowledge, skills, attitude and values in action. It requires competency to transform our society and shape our future. You require the design principles for moving forward and economic and ecosystemic change. So we can conclude that today, as I mentioned, that education is a very ocean. So some point I just try to discuss with respect to by the Arrow of Time in terms of the entropy. So today there has been no satisfactory explanation for direction of time till today. You imagine. We have to live with COVID-19 indirectly or directly for approximately another 2 years. So entropy will decide whether vaccine will be there or not. So entropy only will decide, not the vaccine. That is the thing only I wanted to mention. Thank you very much for giving this opportunity. Thank you.
Well, I would like to express my gratitude to Professor Debabrata Datta for the lovely speech. And of course, I think that everybody has appreciated what you have already said. This is going to be published as we normally do. And I would like to tell the people that the next webinar is going to be on October the 10th at the same time. And the key speaker is going to be one of the organizing committee, Professor Joan Roll. She's the Dean of the School of Business, Medical College, the City University of New York, the USA. And she will be talking about effective teaching and learning in the new world economy, which is something that Professor Datta touched in his speech. Well, I would like to thank everybody. And I don't think we have time for questions unless we try, and if the system cuts off, cut the transmission, well, perhaps we can have one or two questions. Please go ahead. Professor, can you see the chats? And
yeah.
well,
so
it just says...
always welcome some questions, because it's a philosophical thought, not much mathematical, but conceptual. We are all in the entropy world.
Well, there is a congratulation from Professor Ambarasan from Tamil Nadu, Department of Physics, a very distinguished scientist as well. Hello, Professor Ambarasan as well. And well, I would like just to mention that I do appreciate what you are doing. You are helping a lot of people from different countries. And well, what can I say? The last thing I would like to say, but last but not finally, is that we have lost one of our more distinguished friends, Professor Roy Kaufman. And certainly, I think this conference, in a way, and all we have done, you don't mind, is going to be offered for his memory and his legacy. He was one of the greatest fellow I have ever met in my life. So thank you very much indeed to everybody. And we hope that we shall meet on October the 10th. And before that, I'm going to get in touch with some people because I need to make some interviews, right?
Okay. Okay.
So thank you very much indeed, and God bless you all. Bye-bye. Thank you.
Bye. Bye. Thank you.
Thank to you and to your family, Prof. Bye.
Okay. Okay. Bye.
Thank you. Thank you, Ananda.
Thank you, my friends.
Bye-bye.
Bye.
Bye-bye.
Thank you.
Thank you very much. Bye, Prof.
Bye. Bye-bye.
Thank you very much. Bye.
Bye.
Hello, Prof.
Okay.
Bye.
And
Hello. Professor, thank you so much for your nice and wonderful presentation. And it is really a great opportunity to listen to your presentation. Thank you so much, sir.
Thank you, sir. Thank you, sir.
I also like to thank Professor Datta as well for the beautiful presentation and the lecture where the philosophy and science fused together, and it's very interesting. I enjoyed too much. Today morning I just got a call from Dr. Datta to attend this lecture session, and really a fortunate I attended. I also thank to Professor Roberto for giving me this opportunity to attend this lecture meeting. It's very nice presentation. I'm totally pleased. Thank you very much. Thank you all.
Thank you, sir. Thank you to all. So, okay, then can I dismiss our meeting?
yes, I think this is over.
Okay.
Well, once again, Prof, thank you very much indeed.
Yeah. Okay.
And we're going to be in touch, my friend.
Yeah,
Bye.
sure, definitely. Bye.
Bye.